Question number 61. So this is the equation of the circle and we need to find the radius. So we know that this line touches at 2, 3. Now we want to find the radius r. If I draw a line to this 2, 3, that is also a radius. If I know this center, then I know this point, then I can find the distance. So what is the center coordinate? -1 and -6. So -1, -6. Now I have a piece like this. This is 2, 3, and this is -1, -6. In other way, you have to coordinate -1, -6, and 2, 3. What is the distance? The distance is r. R equal -6 minus 2 square y1 minus y2 square plus x1 minus x2 square root. So I think so x1 minus x2 minus 1 minus 2 square y1 minus y2 square root. So this is -3 square and this is -9 square root. This is 9 and this is 81. It means this is going to be 89. Let me check the calculation again. Yeah, 81 plus 9 is 90, not 89. So 90 means 9 times 10, which is 3 over square root 10. Now, what is r is? 3 over square root 10. Also, you can work differently. You can find r differently. When you take the circle, the same circle, the 2, 3 on line on this circle, then you can substitute. It should satisfy this equation. You can work both ways. Since 2, 3 on the circle, it should satisfy equation. Then x value is 2 plus 1 square and y value is 3 plus 6 square equal r square. 3 square plus 9 square equal r square. 9 plus 81 equal r square. R square equal 90. R equal the square root 90. It means 9 times 10, which is 3 square root 10. Part A is done. Second one, part B. Show that the radius 2, 3 is perpendicular to the line. So, not this radius. Radius to 2, 3. Okay, this is the radius. Is perpendicular to this line. It means two lines are perpendicular. How do you show that two lines are perpendicular? Through the gradients. So if I take this gradient m1, if I take this gradient m2, then when I multiply, then you get your answer is -1. What will happen? Then you can tell the lines are perpendicular. So this is the theory behind it. You should know the gradient now. Do you know the gradient of this line? Yeah, equation is given, we can find x plus 3y equal 11, 3y equal minus x plus 11, y equal 1 over third x plus 11 over third. I divide by 3. So this is 1 gradient is minus 1 third. Now what is this gradient? So we have to find. So this minus 1 6 and this is 2 3. So we'll find the gradient. So I will write this gradient is m1 and this is m2. So m2 equal y1 minus y2 minus 6 minus 3 y1 minus y2 divided by x1 minus x2 minus 9 divided by minus 3, which is 3. Now we'll multiply and see that what will happen. Now m times m2 equal minus 1 times 3 equal minus 1. So we got what we want. If they are perpendicular, minus 1. If they are not perpendicular, not minus 1. Now hence, two lines are perpendicular. Or you can write radius at 2 3. Hence radius at 2 3 is perpendicular to the line, perpendicular to the line. Question number 2. There's a circle, so it has a center. Center is 4 6. Now what is the equation of this line? X minus 4 square plus y minus 6 square equal what? R square. If we can find R, then it's fine. There is a point 1 minus 2 lies on the circle. 1 minus 2 lies on the circle. This is also a radius. So we can find this distance. R is x1 minus x2, 1 minus square plus y1 minus y2 square root. 1 minus 4 mean minus 3 square. This is going to be minus 8 square root. This is going to be 9 and this is going to be 64, which is 73. So R equals 73. We need R square. R square equals 73. Equals 73. Now this is the circle. Now next part is we have to find this is a tangent at P, the equation of tangent at P. Now I know a point. One point on this line. 1 minus 2. Now I want to write the equation of this line. Then I need either 1 point or gradient. we can get the gradient because these are perpendicular. Those two lines are. Hence, if I know the this radius gradient or gradient of this line, then I can get the gradient of this line. So we'll work around now. I'll write this is O, not O, we'll write AP, and this is L line. So you can name always 1 minus 2. Gradient of AP equal y1 minus y2 divided by x1 minus x2 minus 8 divided by minus 3, which is 8 over 3. Now ML perpendicular to MAP. Hence ML times MAP equal minus 1. So ML times MAP mean 8 over 3 equal minus 1. ML equal minus 3 over 8. And now I found out the gradient minus 3 over 8. Now you can write the equation y minus y1 equal m times x minus x1. Now we know this point 1 minus 2 on the line. So y minus 2 m mean minus 3 over 8 x minus 1. So y plus 2 equal minus 3 over 8 plus 3 over 8. So this is y equal minus 3 over 8x plus 3 over 8 minus 2. So y equal minus 3 over 8x minus 13 over 8. Question number 3. The point AB with the coordinate AB. So A coordinate is minus 1, 9. B coordinate is 7 minus 5. To find the equation of the perpendicular bisector of the line segment AB. This is AB. So bisector means it should go be middle. It should be equal. Now this line is a perpendicular bisector, but it has to be perpendicular. Then this is the perpendicular bisector. Now I want to find the equation of this perpendicular bisector. We discussed in the previous exercise. Since this is middle, we can find the middle coordinate of this middle point. Also, I can find the gradient of AB. Hence, I can find the gradient of this line and then I can write the equation. So, I will take L1. Now, first of all, I found MAB, gradient AB. 9 minus 5 divided by minus 1 minus 7. This is 15 and this is going to be minus 8. So minus 7 over 4. I think this is minus 1 minus 9 and 7 minus 5. Now it is fine. minus 9 plus 5. So this is going to be minus 4 minus 8. So this is going to be half. So I decide to check again the figures because I realize that it's not familiar. I mean, it's not a good fraction. So I thought there should be a error. That's why I check, and then I realize. So you also can use that sense when you work with that. If you see that the peculiar is in a fraction, then you can go and see, double check for the accuracy. Now I know the gradient is half. So I know gradient is half. MAB is half. Since this is perpendicular, then I can find L gradient. AB is perpendicular to AB is perpendicular to L. Hence, gradient of AB and gradient of L, when you multiply, you have to get minus 1. So gradient of AB, you know, half, and this is ML is minus 1. Then ML is going to be minus 2. Now the gradient of this one, you know, minus 2. In this line, you know, gradient is minus 2. Now you need a point on this line. If you pick up this intersection point, so intersection point is on this line as well as intersection point on this line. So what is this point? It is the middle point of AB. So mid point of AB. How do you find the midpoint? X1 plus x2 divided by 2 minus 1 plus 7 divided by 2. Y1 plus y2 divided by 2. So this is 6 divided by 2, 3. And this is 14 divided by 2 minus 7. Now 3 minus 7 is on this line. Now I can write the equation y minus 1 equal m times x minus x1. Y minus 7 y value equal m in minus 2 times x minus 3. It means y plus 7 equal minus 2 times x minus 3. Y plus 7 equal minus 2x plus 6. Y equal minus 2x minus 1. My question now, did I use any circle properties here? No, still I didn't. AB is just a segment. And those are the AB coordinates. I didn't use any circle properties yet. Now we want to show that if AB is on the circle, if AB on the circle, that's the data given actually, then this perpendicular bisector go through this line. We want to check. We want to show that. We know the equation of this line is y equal minus 2x minus 1. Now what is the center? Center is 1 minus 3. Now we found out the center is 1 minus 3. Now we don't need anything. Now we want to check that this center 1 minus 3 is on this y equal minus 2x minus line. Even this line doesn't know this is a center or not. Line knows that there is a point a known point on the curve. That's all basically. Now I want to show that this point is on this line, or this point make happy this equation. It means this point satisfy this equation. Okay, let's see what is the meaning of satisfy. When you substitute those coordinate to this equation, the inequality stay the same. Then the equation is happy. So we'll write now. Um, to check minus 1 3 point, no, 1 minus 3, 1 minus 3 point on y equal minus 2x minus 1. Now there is no any circle properties here. This is just a point and this is just a equation. I want to check that this point is on this line. To check. So I will take LHS equal y, left hand side of this y. What is the y value? Minus 3. RHS, right hand side is minus 2x minus 1. It means minus 2, what is the x? 1 minus 1 minus 3. Now you can see both numbers are equal. It means equation is happy. Hence LHS equal RHS. Hence 1 minus 3 satisfy the equation y equal minus 2 minus 1. Then what is 1 minus 2? Center of the circle. Hence, center of the circle. What is this? Y equal minus 2x. Perpendicular. Hence, center of the circle on perpendicular bisector of AB. Question number 4. PQ, there is a line segment, and this is 3n1, and this is 5n minus 3. Part A is find the equation of the perpendicular bisector of the line PQ. Okay, this is the perpendicular bisector. We'll work out as usual. This is L1. The gradient MPQ is y1 minus y2, 1 minus minus 3 divided by x1 minus x2. This is going to be 4 and this is going to be minus 2. So answer is minus 2. Now PQ is perpendicular to L. Those are perpendicular. Bisect and also perpendicular. Make 90 degrees. PQ is perpendicular to L. Hence, MPQ times gradient of L make minus 1. MPQ is minus half time L is minus 1. ML is half. Now I know this gradient. I know gradient of this line, half. Now I need a point on this line. I know this point belongs to PQ and this point, the same point belongs to L, common point. So if I manage to find the middle of PQ, then I know that point also lies on this L. Now we'll find the middle of PQ. So PQ is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So this is going to be 8 divided by 2, 4, and this is minus 2 divided by 2, minus 1. So this point is going to be 4 minus 1. This point is going to be 4 minus 1. Now I have the gradient and the point, so I can write y minus y1 equal m times x minus x1. Y mean y minus y1 mean minus 1 times m mean what is the gradient? Half a times x minus x1 is 4. So y plus 1 equal half a x minus 2. Y equal half a x minus 3. So equation of this line is y equal half a x minus 3. Now I want to show part 2 is show that the perpendicular figure passes through the center. This perpendicular line should go through the center. Then I want to show that in other way this point should satisfy this equation. Then I should know the point which is center. So now I have to find the center. I will rearrange this one: x square plus y square minus 4x plus 4y equal to. Now this is x square plus y square plus 2fx plus 2gy equal minus c equal 0. So this is minus 2 equal 0. I'll take 2 to the left side. Now 2f is minus 4, f equal minus 2. 2g is 4, g is 2. Now center is minus f minus g. Then minus f mean minus 2 and minus g mean 2. So center is going to be 4 minus 2. Sorry, not 4, 2 minus 2. So now I found out the center. Now I have an equation y equal half x minus 3 and point on this line. We don't know this point is here. Okay, I will take this point is 2 minus 2. So if this is on the line, the equation should satisfy. So we'll check that. If 2 minus 2 on y equal half x minus 3, then it should satisfy the equation. We'll check. LHS equal y. What is the y value? Minus half. Minus 2. Right hand side is half x of the equation. Half x means 2 minus 2, which is 1 minus 2. This is minus 3. So 1 minus 3, which is minus 2. Hence LHS equal RHS. Hence 2 minus 2 satisfy the equation y equal half x minus 2. It means this should be not outside on the line. Hence 2 minus 2 is 1. Hence center of the circle on the perpendicular bisector. Perpendicular bisector of PQ.